This is Algebra 2 with Trig, 7A.4 worksheet, and also the 7A review sheet. So what we're looking for is, for the sequence, we're going to write the next term and we're going to write an explicit rule for the sequence. So we can look here and we're trying to figure out what the pattern is. There's different ways that we can identify. If we say 2 divided by 6 minus 2 divided by 3, we're going to subtract those two. We're going to get negative 1/3. 2 divided by 9 minus 2 divided by 6, we're going to get a different value. So this is not arithmetic. And we're not multiplying. We can test that one out too. One way to test it out, we can do it by hand. 2 over 6 times the reciprocal. So we got 1/2. And 2/9 times its reciprocal. 3 goes into there 2 times, 3 goes into there 3 times, so it's 2/3. Not geometric. So it's considered neither. So now we have to use our positions. This would be position N. So we notice the numerator is always 2, and the denominator is 3 times the position. So the first thing I did was rule out that this wasn't arithmetic. I used my calculator to help do those calculations quickly. I showed handwork to show you that it's not geometric. So it was neither, and there's our rule using our position. Here we see that we're going up to become positive, but then we're going down, then we're going back up, so it's not arithmetic. We're timesing by 2, actually like a negative 2, but then no, that's not timesing by the same amount, so it's not geometric. So this is neither. So we're going to use our position. Remember, this is N. And we notice that 4 times 1 and 4 times 2 and 4 times 3. So 4N is multiplying to make our term, but the sign seems to be alternating. So one way we can handle this is by putting a negative out in front, and in the first one we plug a 1 in, so it's negative 1 to the first power, which is negative 1 times 4n. Gives me a negative. The second time we have squared, so a negative squared becomes a positive, and a positive times 4n gives us positive 8. Here we're looking at this one. It is not arithmetic. We're not adding the same amount every time. We're not multiplying by the same amount every time. Well, as I look at this, actually it's not neither. It's what happens when you kind of do it in your head. We could still get it by doing position. Totally works. Real simple. But since I said it wasn't arithmetic, let me show you that if you take your number and you subtract the 1 in front of it, 2 minus 1 is 1/4. If we take 3 over 4 and subtract the 1 in front of it, 3 minus 2 is 1 over 4. So we have this common difference of 1/4. If we would continue the pattern, it would do the same thing. So this is arithmetic. And what we're going to see is that if we're going to use this y equals mx plus b format, where our first term is 1/4, so that's our y and 1 is our x, we can say 1/4 equals our slope times our x plus our b. When we multiply by 1 and subtract it across, we're going to get b equals 0. So we're going to have a of n equals our slope times n, or n over 4. That would have been the position that you found. 1, 2, 3, 4, 5, that's following your position, and it's always divided by 4. So either format is correct, but this is arithmetic. We look at this one. 7 minus 12.5, that gives us negative 5.5. 1.5 minus 7 gives us negative 5.5. Negative 4 minus 1.5 gives us negative 5.5. So we have this common difference of negative 5.5. So yes, this is arithmetic. So we know our first term. Let's use our second term this time. Let's use a of 2 equals 7, so I'm not dealing with that decimal, even though maybe with this it would have helped, but I already started this way. So 7 equals our common difference, which is negative 5.5 times our x plus b. So that works just fine. So we get 18 is our b value. So a of n equals our slope n plus 18. We can test that out by saying negative 5.5 times our position, 1, 2, 3, 4, our fourth position, plus 18, it should give us the answer of negative 4. So I tested it to verify that it was working. This next one, we see that the 15 divided by 3 gives me a 5, and the 75 divided by 15 gives me a 5, and apparently the 375 divided by 75 gives me a 5. So I have this common ratio of 5. This is geometric. I know my a of 1 equals 3, so it's real simple to write. It's 3 times 5 to the n minus 1. And we can test that out if we want to use our calculator to verify. 3 times 5 to the power, and let's look for the third one this time. So 3 minus 1 gives us 75. So now we're increasing by 3, then we're increasing by 5, increasing by 7, so we're not going up by the same amount every time. It's not a multiple, so this would fall under neither. So that means we're going to use the 1, 2, 3, and 4, use the position. And if it was simply adding or multiplying, we would have figured that out with arithmetic or geometric. But so let's try squaring. So if we square the 1, that gives us 1. We need 5 more. Square the 2, that's 4. We need 5 more. Square the 3, that's 9. We need 5 more. So it's the position squared plus 5 more. Alright, this is more officially into the review now. This is a review on sequences. Let me slide back here quick though. Now I read the directions and it says that we need to write our next term. Alright, so if this was a 5 and we're going to follow our rule, it would be 2 over 3 times 5. That would have been our next term. Here, if we were working with the 5, we would have 4 times 5, which is 20. And when you have a 5, it'll be negative, so negative 20. One over 4, 2 over 4, all the way up to 6 over 4. That would be our next term. Here, we're going down by 5.5, going down by 5.5, going down by 5.5. So this would be negative 9.5. We should be able to figure that out when we would type negative 5.5 times our n, which is our 5th term, plus our 18 should give us that negative 9.5. So we're timesing by 5, timesing by 5, timesing by 5. 375 times 5 is going to give 1875. You could plug that into your formula also. 1, 2, 3, 4, so our 5th position, squared it is 25, plus 5 would be 30. That's going to be our next term. Down here we're supposed to write our first 5 terms. Well, we'll call a of 1 our first term, and it says 2 times your previous. So a of 2 says 2 times your previous, so it's going to be 6. And the previous was 6, so now it's 12. $24. 2 times 24 is 48. So 3, 6, 12, 24, and 48. So this is a recursive because we're using a of n minus 1, which means to use the previous term. Here's a recursive rule. Again, it tells us where to start. So if that's a of 1, a of 2 is going to be plugging the 3 in for that spot. Plug the 8 in. $13 in. And the 18 in. Now this here, this is an explicit formula. Little trickier because we need to figure out a of 1, we have to plug in a 1. So 3, 1 minus 1 gives you 0, 3 to the 0 power gives you 1. 3 to the 2 minus 1 gives you 3. 3 to the 3 minus 1, which is squared. 3 to the third is 27. And our last term is going to be 3 to the 4th, which is 81. So 1 minus 2 gives you negative 1 over 1 squared. Plug in a 2, so 2 minus 2 over 2 squared, which is 0 over 4, which is 0. Interesting. Plug in a 3, we're going to get 3 minus 1, which is 1, over 3 squared, which is 1/9. 4 minus 2, which is 2, and 4 squared is 16, so that's 1/8. 3 over 25. Looks like our next set of directions are here on the bottom. Tell whether the sequence is arithmetic or geometric and explain your answer. Then write a rule for the nth term. Okay. Looks like we go up by 5, up by 5. So this is arithmetic. Increase by 5. D equals 5. It's a common difference. If we're going to do a recursive, remember we need to first show where we're starting. Then we would show the pattern of what we're doing, which is to take the previous term and add 5 to it. For an explicit rule, that means we need to use our position, or we could even, since this is arithmetic, we can use y equals mx plus b. So I know that my first term is 1 and I get 1, and I know that d equals 5. So 1 equals 5 times 1 plus b. So 1 equals 5 plus b. Subtract that across. So I'm going to get a of n equals 5n minus 4. Here it looks like we're timesing by 9 times 9. So our r factor, this is times 9 times 9. So this is geometric. Common ratio equals 9. The recursive rule, we have to show where we're starting with. So we're starting at 1/3. You just can't write the pattern. You have to show where you're starting with. And for a geometric, we always put our value first, our ratio, times the previous term. So here, this is going to be a of n equals r times a n minus 1, where over here was a of n equals n minus 1 plus d. So our explicit rule, this is multiplying. We know our rule is going to be a of 1, r, n minus 1. So our first term is 1/3. Our common ratio we determined was 9, and it's to the power of n minus 1, because that's the formula. Looks like we're going down by 4, or up by 4, and up by 4, and up by 4. So D is going to equal 4. So this is arithmetic. Common difference equals 4. So if we take our position, 1, 2, 3, let's take the third position. A of 3 equals 3. So that's our y value. We know our slope is our common difference. Our n is our x value. So we have 3 that equals 12 plus b, and we subtract that across to figure out b is going to equal -9. That, I guess this is working on the explicit rule, huh? And this is a of n equals 4n minus 9. We should be able to test that. 4 times position 1, position 2, position 3. Let's go to position 4 just for fun. And it says -9. And I expect to get an answer of 7. It worked out great. The recursive rule, we have to show where we're starting. And then the pattern. Remember, we're adding 4 each time. So this is the previous term plus 4. One, 2, 3, 4. Now we're down to 1, 2, 3. Then we're down to 2. Then we're down to 1. So it looks like we're dropping a 0 every time. We're dividing by 10. So this is a ratio of 1/10. So this is geometric. This is a common ratio equal to 1/10. So our recursive rule, it tells us that we're starting out with 10,000, and our ratio is 1 over 10, a of n minus 1. The explicit rule, since we know what our ratio is, our first term is 10,000 times our ratio, n minus 1. Number 6. Write an explicit rule for the nth term of an arithmetic sequence when these are the situations. Alright, so these are 2 points. So we have the point 3, 29, and we have the point 11, 101. So this is arithmetic, so we need to find a slope. So 101 minus 29 over 11 minus 3 . 72 minus, or over 8. That'll go in there 9 times. So that's our slope. So I have a point. So if I use my idea of, oh, I'm sorry, you couldn't see any of that. So 101 minus 29 over 11 minus 3 gives me my slope, which is my common difference. And then we will take our point with our slope and our x plus b. 29 equals 27 plus b. So b is going to equal 2 when we subtract it across. So our answer to number 6 would be a of n equals 9n plus 2. So if we have 9n plus 2, if we plug in 11 and add 2 to it, we should get our answer using this point right here. The 11 for our x and our formula. we should get 101, which is what we had. Okay, write an explicit rule for the nth term of an arithmetic sequence when we're given 2 points. So just like before, we're going to take our point, our y value, minus our y value. Those are 2 negatives, make a positive. And our x value minus our x value. So this is 61 over -3. That's kind of weird. Let's look at that one more time. So I chose to start with this number minus that one. So 5 minus 8. That's 51. That's better. Alright, so that's -17. And we'll take our point, 25, equals our slope times our x plus b. So that's 17 times 5 is -85. So we're going to add our 85 across. That's 110. So for number 7, we've got a of n equals our slope of -17n plus 110. We can test that out. Take -17 times our point, which could be 5, plus 110, and we should get our answer of 25. Perfect. For number 8, write an explicit rule. It's a geometric sequence. Notice that in this geometric sequence we know what a of 1 is. Makes this a lot easier. So we're trying to do a of 1 times r n minus 1. So -16 equals 2 times r n minus 1. Well, the n is going to be 1. That's, we get 2. Let's see, we're plugging in our 16, so this would be a 4. So our n is 4. So -16 equals 2r to the third. We'll divide by 2. Gives us r cubed. We'll take the cubed root of 8. So that gives us -2 for our r. So now we're ready to write our rule, which is a of 1 times -2 to the n minus 1. Remember, you can never multiply these two together because it has an exponent. And that would be our rule. We can test that rule. Never a bad idea to try to test it. So we have 2 to the -2 raised to the 4 minus 1. And that gives us the -16 answer. 4 minus 1 will give us -16. Alright, last one. Now here we don't have the a of 1, so we've got to calculate that. So we're going to start out with 729 equals, we don't know a of 1, we don't even know our r. We use 129 when our n value is 2. So that's 729 equals a of 1 r to the first power. So 729 over r equals 1. We divide by that r to get r underneath the 729. Now we're going to come over and use our other point. 9 equals our new a of 1, which is 729 divided by r, but our new r value is 6. So that's 9, 729 over r to the fifth. These can reduce. 729 r to the fourth. We have 5 on top, 1 on bottom. They reduce out to become to the fourth. So I'll divide by 729. So that can be reduced a little bit. I know that 729 can be divided by 9 is 81. So this is going to be 1 over 81 is r to the fourth, which when I take the fourth root of that, I get plus or minus 1/3. So now we're going to need to bring that over here, and we get 729 over a plus or minus 1/3, which we have to multiply by the reciprocal and times it by 3. So 729 times 3 would give us a plus or minus of 2187. So we're ready to write our final rule for number 9, and that is a of 1, which was 2,187. With a positive 1/3 n minus 1, or with a negative. So we have a negative 1/3. We also have a negative 2187. Kind of point out a little bit here what's going on. When we took the fourth root, that was an even number. So we took the fourth root of 1 over 81. That got us a plus or minus because it's even, and even roots got to give us plus or minus. And the fourth root of 81 is 3, so that's why it's in the denominator. So it's a plus or minus. When we brought it over here, we were dividing by that same r value, which was plus or minus, which means we multiply by the reciprocal, multiplying by a 3 or a negative 3. So we get two different, oh, that's not r. Sorry, this is a of 1. Sorry about that. That gives us two different a of 1 values. So we have two different formulas we could possibly use. One when the a of 1 is positive and the r is positive, or a of 1 is negative and the r is negative. Good luck.